Hello everyone, welcome to this session on Centroid. And basically first we'll have a small derivation related to the individual elements that will come across in the Centroid and which will be helpful for the solution related to the numerical problem on Centroid. So basically Centroid is a position wherein the concentrated area will be placed at a single location, which will help in the analysis and design of the element. So first part is the centroid of the triangle. So consider a triangle of base B and height h. Consider a triangle of base B and height h, and we need to find out the centroid of this particular element. So to find out the centroid of the element, area of the triangle is half base into height. So this is nothing but the centroid, that is the total area of the elemental, that is nothing but the area of the triangle. Now within this particular elemental area we shall consider a thin strip, and that particular thin strip will be taken along the horizontal section. If we consider a thin strip along the horizontal section which will be of thickness dy and base width b1, and this particular elemental strip what we have considered will be an elemental strip which will have a varying base with respect along the vertical height, which means when it is been placed along on the x-axis, the total b1 will be equals to b. That is, when it has been placed on the x-axis, b1 will be equals to b. When it is been placed at the tip of this particular section, b1 will be approximately equals to 0. That is, it will be approximately coinciding here. Now to begin with the solution, we shall consider an x-axis and y-axis. Reason for considering this as x-axis and y-axis, b1 shall vary, that is, it will vary along with respect to the height. So for that reason, there is an integration limit that it will start from base of the triangle till the height. That means the integration limit will vary. To have that particular integration limit, we will have a variable that is called as y. So y will vary with respect to 0 to h, that is with respect to the base till the upper portion, which is 0 to h. Now to find out the elemental area, dA will be equals to b1 into dy. That is nothing but a thin rectangular elemental strip whose base is b1 and thickness is dy. So area of rectangle is b into d. So area of the elemental strip will be b1 into dy. So this is what is the area of the elemental strip. To start with, we need to express b1 in terms of the common terms b and h. To express in terms of common term b and h, this particular height above this particular portion, total height is h, and the location of this particular elemental strip is y. So which indicates the remaining left out height is h minus of y. That is, from total height h you are going to subtract y, and the remaining left out height is h minus of y. So from principle of similar triangle, it will be calculated as, that is, b1 will be calculated as h minus of y divided by b1, that is height of the smaller triangle divided by the base of the smaller triangle, is equal to h divided by b, that is height of the bigger triangle divided by base of the bigger triangle. So b1 will be equals to b by h into h minus of y. If you cross multiply here, it will be b1. If you cross multiply here, it will be b, and h will come in the denominator. So this is what is the value of b1. Substitute the same value of b1 here. So dA will be equals to b by h minus of y into dy. So this is nothing but the area of the elemental strip, that is b by h into h minus of y into dy. Now we need to consider this in the calculation for centroid now. Now calculation from centroid from the first principle will be a into y bar is equal to integration y dA. So this is what is the calculation of centroid from the first principle. Now area has been calculated a half base into height, that is nothing but the area of the elemental strip, into y bar integration y, and area of this particular elemental strip is this part now, which is b by h into h minus of y into dy. That is dA is calculated here. And how dA is calculated? By considering this as a rectangular area. This is a rectangular elemental strip. So area of rectangular elemental strip is b into d. So b here is b1 into dy. So this is what is b1 into dy. Now b1 is expressed in terms of the whole common term as h and b from the principle of similar triangle. From the principle of similar triangle, height of the smaller triangle divided by base of the smaller triangle, height of the bigger triangle divided by the base of the bigger triangle. So considering this part, this is what is the dA elemental strip now. So we need to resolve this particular part to find out the value of y bar. So to resolve this, expand the term as it is, half base into h y bar. So this will be b by h, take it outside because it is constant and it is not to be integrated. Integration will be done with respect to dy. So integration hy minus of y square into dy. This is what is the term for the y bar term now. So here b and b gets cancels up. So y bar will be equals to 2 divided by h square. 2 means it will go on towards the right hand side, h square will come in the denominator. Integration hy minus of y square dy. So this is what is the term for y bar. So y bar will be equals to, so solving this part, 2, keep it as it is, integration, take integration y divided by h square, that is nothing but the first term, minus of y square divided by h square. So this is what is the second term here. Now we need to integrate and then find out the solution. Now before finding out the solution of this term, we need to substitute some of the variables, that is nothing but the constant of integration, and those constant of integration terms we need to substitute. Now what is the constant of integration here? Variable term is y. So constant of integration that I am going to substitute is y now, and y varies from 0 to h. So here it will be 0 to h. So after substitution of 0 to h as the integration limit, because y varies from 0 to h, so we need to find out all the individual term. To find out the individual term, we'll have this particular simplification, that is 2 integration 0 to h y divided by h, that is h and h square gets cancelled up, minus y square divided by h square integration dy. So 2 0 to h y square by 2 1 by h as it is, y square by 2 minus 1 by h square y cube by 3, that is integration of y square will be y cube by 3. So this part will be substituted with the integration limit as 0 to h. So this is 2 and 2 kept as it is, and substitution of y square in terms of h will be h square divided by 2h minus, here after substitution this will be h cube divided by 3h square. So solving this, h gets cancels up, 2 as it is, h by 2 minus h by 3. So what will happen here is 2 3h minus 2h divided by 6. So this will be 3h minus 2h will be h by 3, because 2 1s are 2 3s are. 3h minus 2h will be h, 2 1s are 2 3s are. So this is nothing but the value of y bar with respect to the centroid along the vertical direction. That is, with respect to the base, the centroid is placed at a distance of h by 3. That is what is the value of the centroid that will be placed with respect to the base of the axis. Now why with respect to the base of the axis is because x-axis and y-axis have been drawn with respect to the origin. So from this particular location, if you can redraw the triangle again, from the horizontal x-axis, vertical, the total height is h here, and from the origin, that is from the 90 degrees angle, the centroid distance is h by 3. If the centroid distance is at a distance of h by 3, total distance is h, which means the remaining distance shall be h minus h by 3, which is nothing but 2h by 3. So from this hypotenuse point, the centroid distance will be 2h by 3. This is what is the centroid with respect to the vertical. Likewise, we need to calculate the centroid with respect to the horizontal. To find out the centroid with respect to the horizontal, consider a triangle again, right angle triangle, whose height is h and base width is b. And the thickness of this triangle is dx. and its height is called as, now there it was called as the dy, here this was dy, here it will be called as dx, here it will be called as b1, now here it shall be called as d1 because it is the depth of the triangular section d1. Now we need to find out the area of this elemental strip. dA will be equals to d1 into dx. dA will be equals to d1 into dx. So area of this strip will be half base into height. Area of this particular strip will be half base into height. Now since we are calculating centroid with respect to the horizontal direction, a into x bar will be integration x dA. A into x bar is equal to integration x dA. Now substitute the whole term here. Now before substitution, I need to express d1 in terms of h. The same procedure that we had adopted here, that is the expression of b1 in terms of b. So here also we need to express d1 in terms of h. To express that particular part, if this is placed at a distance of x, remaining distance will be b minus of x, that is capital B minus of x. So here to solve this, apply the principal triangle here. H by b, that is height of the bigger triangle divided by base of the bigger triangle, is equal to d1, that is height of the smaller triangle divided by base of the smaller triangle is b minus of x. So d1 will be equals to b minus of x into h by b. So cross multiplying h by b as it is, d1 will be equals to b minus of x into h by b. So if I substitute in this dA term now, so dA term when I substitute, dA will be equals to b minus of x h by b into dx. So d1 is b minus of x h by b and thickness of the strip is dx. Substitute the term here now. Area of the triangular strip is half base into height into x bar integration. X is as it is. This particular term when we substitute, it will be b minus of x h by b into dx. This is what is the area of the elemental strip, that is this is b and this will be thickness of the elemental strip. Now to solve this, half base into height x bar as it is, integration. So h by b take it outside, so integration this will be bx minus of x square dx, and integration term we need to substitute the limits or else we need to express it in terms of constant of integration. To substitute the values of the limits of x, so x limit will be, as axis has been considered with respect to the base, that is x-axis and y-axis, so limits will be, it starts from the origin O, that is x will start from the origin O and it will terminate at this particular position. So for that reason, limits will be 0 to b, x limit will be 0 to b. On the other hand, y limit was 0 to h, it was proceeding along the vertical direction, whereas here the traverse of this elemental strip will be along the horizontal direction. For that reason, limits will be 0 to b. So here the limits will be 0 to b. So h by b, keep it as it is. Integration b, here integration of x will be x square by 2 minus integration of x square will be x cube by 3, 0 to b. So these are nothing but the values now. So this part when we substitute as it is, half base into height into x bar, h gets cancels up, x bar will be equals to 2 divided by b square, b, and substitute the value of b here, this will be b square divided by 2 minus of b cube divided by 3. Second term when you substitute it will be 0. So simplifying here, 2 divided by b square, b cube divided by 2 minus b cube divided by 3. So here x bar will be 2 divided by b square, b cube divided by 6. X bar will be 2 ones are 2 3s are b square, b cube gets cancels up. So in the denominator it will be b, in the denominator it will be 3. So x bar will be equals to b by 3. And y bar value was how much? H by 3. So if you want to interpolate these points on the triangle, consider a triangle here of base b and height h, and mark this particular point here. This particular point with reference to the origin, this will be b by 3, and with respect to the height it will be h by 3. So this will be h by 3 and this distance will be b by 3. So this is what is the calculation of centroid for a right angle triangle. Now how to remember this is, consider this a right angle triangle. In for particular right angle triangle there will be two positions here. These 2 points, if I name this as A, B and C. B and C are the position, B and C are the position of the hypotenuse end. A is the position, B and C are the position of hypotenuse end. A is the position of 90 degrees angle. A is the position of 90 degrees angle. So if reference to position of this hypotenuse position and with reference to the angle position, we need to mark this particular distance b by 3 and h by 3. To mark the particular position, mark the 90 degrees angle. With reference to the 90 degrees angle, the particular centroid distance along the vertical is h by 3. Along the horizontal it will be b by 3. Likewise, if you have a triangle in the other form, like if the triangle has been placed in this particular fashion and the origin is placed here, that is, for example, the origin has been placed here now. Now, when we want to proceed from the origin O here, we need to check out whether we are proceeding from the 90 degrees angle or from the hypotenuse point. To mark that, we shall mark these particular points as it is. So here at 90 degrees angle it will be A, at hypotenuse point it will be B, and again at hypotenuse point it will be C. So from hypotenuse from point P, B and C, from B and from C, this particular distance shall be calculated as 2/3 of base, whereas along the height it will be 2/3 of height. So likewise, since we are proceeding from C, the centroid distance that we need to take care here is, this particular centroid distance will be 2/3 of base, and along the vertical it will be h by 3. So this is nothing but the centroid that we are going to calculate. Other form is if the same triangle, and if we want to calculate the centroid in the other fashion by having a triangle being placed in this order. Here again the centroid distance will be b by 3 and h by 3. If you are proceeding from the origin downward, then this had to be 2h by 3. So these are nothing but the calculation for the centroid that will be helpful while calculating the while solving the numerical problem. Do remember, centroid for x bar and y bar will be b by 3 and h by 3. How to solve this is, consider a triangle of a right angle triangle. Area of right angle triangle is half base into height, and the integration limit when you proceed along the vertical direction it will be 0 to h, and along the horizontal direction it will be 0 to b, because x varies from 0 to b, whereas y varies from here as 0 to h. Then this is from the principle of from the first principle, a into y bar is equal to integration y dA, half base into y bar is equal to y b by h into h minus of y dA. Substituting the whole term and integrating, you will be getting the value of y bar as h by 3, and here substituting the whole term here and integrating, you will be getting the value of x bar as b by 3. So this is how we are supposed to find out the centroid of a triangular section. So notes will be attached to this. If you have any doubts, you can ask. Thank you. Have a nice day.